In this video, we are going to cover the periodic functions terms and also how to graph sine function, the parent function, and from the y equals sine x, how to do the transformations to graph other sine functions. So for periodic functions, it means it has a repeating pattern. So any graph that repeats itself, we call it a periodic function. So you just randomly graph something that you have a pattern, it repeats itself, we call it periodic function. And the some terms we need to know in order to describe a periodic function. So cycle is one complete pattern, and it could begin at any point on the graph, but it just ends at the same point on the graph, then that will be one cycle. And we pick the smallest part that could repeat the whole graph. So this is one cycle, and the length of one cycle, the horizontal distance for one cycle, we call it period. And amplitude is half of the overall height. So from the maximum, take away the minimum, divided by 2 is your amplitude. Or you could think it's from the middle up or down, the same amplitude. Amplitude is always a positive number, and the midline is middle of the graph. So maximum plus minimum divided by 2, average of maximum minimum. So we are going to see from a given periodic function how we can find those cycle, period, amplitude, and midline. So this one, from this point to this point, if we cut this part out, repeat it, you could generate this graph. So we call this from 0 to 3, this is a one cycle. And the distance, horizontal distance, we call it a period. So for this one, the period will be 3. And maximum is the maximum height of the whole graph is 4. Minimum is for y value for the whole graph is 0. And amplitude is half of the overall height. So it will be 4 minus 0 divided by 2 is 2. And midline is middle of the graph. It is average of the maximum and the minimum. So it's maximum plus minimum divided by 0, divided by 2. 4 plus 0 divided by 2 give you 2. Although they are same number, but midline is this horizontal line. And the amplitude is from the horizontal line up to the maximum or down to the minimum. This is your amplitude. The domain for this one, if it stops here, then it will be from the minimum of x is 0, maximum for x is 9. So it will be from 0 to 9. So we put minimum here and the maximum on the right side. Use less than equal to, less than equal to, because no open dot. And the range is from minimum to maximum is from 0 for the y to maximum. Or you could write it as interval notation is 0 to 4, square bracket. And this one, interval notation is 0 to 9. So this is for reading from the graph. And after that, we are going to practice on finding the period, amplitude, midline, domain range again for this given graph, and also we are going to practice on the function notation. So f at file, we call it function notation, and file is your input. F and 5 is when x equals 5, y equals what? So we are going to look at x equals 5, the y value is 1. So 5 comma 1, it means the y value is your f at 5. So it's equals 1. And when f at x equals 5, it means y equals 5. Then x equals what? So f at 5, y equals 5, then x equals, the point of intersection give you the x value. So this one is around negative 2.5, and this one around positive 2.5. So x equals negative 2.5 and positive 2.5. The period is one complete cycle, so you could pick any point. So you could pick from this point to this highest point, or you could pick from the lowest point to lowest point, this on the grid. So from 0 to 5, the period is distance of one cycle is 5 minus 0. So the distance means subtraction. So period is 5. The amplitude is maximum, minimum, the half of the overall height. It will be 1/2, half of the maximum minus minimum. Maximum is 5, minimum is 1. So it gave you 2. So amplitude is 2. The midline is the middle of the maximum minimum. It will be 5 plus 1 average. It gives you 3. So if we write it, it will be the horizontal line. We need to write it as y equals 3. So midline is not one number. You need to write it as an equation. Horizontal line, on this line, all the y values same, so y equals 3. The domain, we have arrows at both ends, so it will be all real numbers. And if we write as site notation, it will be x belongs real numbers. And for the range is y belongs all real numbers because solid line, and y minimum is 1, maximum is 5, y in between, so less than equal to, less than equal to, because there's no open dot at the maximum minimum. And we practice more to find apply the periodic function property. So f at 10 equals what? So we don't have 10 on the graph, but we know that the period is 5. So we could f at 10 also, it should equals f at 5. So 5 plus 5 a period give you the same point repeat. So this 5 give you the y value is 1. And f at 15, so 10 plus 5 give you 15. They should have the same y value, so it is 1. And f at 1 is 2.2, okay? So it will be 2.2. The f at 6, if we read it, is around 2.2. And the f at 106, we are going to see each one is 5. So 5 times 20 is 20 cycles, then plus 6. After 20 cycles, it should equal, if we go back 20 cycles, it should equal to f at 6, so it will be 2.2. Or we could write it as 5 times 21 then plus 1. That is f at 106. It is equals to f at 1. So it repeat 21 cycles, go back to f at 1. So it is 2.2. This is a periodic function. So after one cycle, that point has the same y value. It repeats itself. So that is for the periodic function. Then after that, we are going to see how we can graph. We are going to graph the sine function. So for the sine function, use your calculator, find all the values for this 0 degrees, 30 degrees, 60 degrees, 90 degrees. And after that, we are going to use a table of values to graph. So I will just fill in. So sine x is 0, sine 30 is 0.5, sine 60, it is square root 3 over 2 is 0.866, and sine 90 is 1, sine 120 repeated, and 150 is 0.5, 180 is 0, 210 is negative 0.5, negative 0.866, negative 1, and negative 0.866, negative 0.5, 0, 0.5. It is after 360. This is a unit circle. After 360, we know it's coterminal angles. It will repeat. So 30 equals 390, and the 420 equals 60. It's just repeat itself. And 0.5. And also we could see it from this unit circle. So unit circle means radius is 1. We put this unit circle onto xy coordinate system. Then we know if we have an angle theta here, this is hypotenuse is 1. The sine theta is opposite over hypotenuse. Hypotenuse is 1, so opposite equals sine theta. And the cosine is adjacent over hypotenuse. Hypotenuse is 1, so adjacent is your cosine theta on the unit circle. So for sine theta, compare it with the table of values. You will see sine theta is the y coordinate of the point, and x is cosine theta for the point on the unit circle. So for this point, it's 1, 0, and it's 0 degrees, so y value is sine 0 degree, is 0. And for this 90 degrees, sine 90, the y coordinate is 0, y, so sine 90 give you 1. And sine 180 is negative 1, 0. The y value is a sine, so sine 180 is 0. And sine 270, this point is 0, negative 1. So sine 270 is negative 1. Go back to 360 is 0. So these 5 points, 0 degree is y value is 0, 90 degree is 1, Then 180 degree go back to 0, 270 down to -1, then 360 go back to 0. So these 5 points will give you a rough shape of the y equals sine x. So we are going to do the graph using the table values. So we are going to label it. Every 2 we label it 30 degrees. So each of one grade is 15, 60, 90, then 120, 150, 180 degrees. So after that, I will just go 210, 240, 270 degrees, and 360 degrees. So 0 degrees give you 0. And I will go by the maximum we know is 1.0. So go by 0.25. So 0 degree, 0, 90 degree is the highest point is 1. 180 go back to 0. Then -270 go down 1. This is -1.0, -0.5. And 360 is go back to 0. And 30 degree is 0.5, and 150 is 0.5, 210 is 0.5, this is 0.5. And we are going to connect them. And this is your y equals sine x. So this is your parent function, y equals sine x. And in future, you just need to graph these 5 key points. 0, 0, 90, go up to the highest point, and 180, go back to the middle, 270, down to the 1, -1, then 360, go back again. So it's kind of like up, down, then up. So same as a y coordinate. And from the graph, we are going to see the amplitude. So the amplitude is from middle to the maximum. So that is from middle go up to the maximum. This is your E value is 1. It's amplitude from middle to the minimum. That is your amplitude. And also you could do the calculation is maximum minus minimum divided by 2. It is 1, take away -1 divided by 2, then you have 1. The period is, if we continue, you will see it is repeated itself. So the whole circle from here to here, the whole circle is 1 cycle. So it's 360 degrees. And domain is, you could turn this way or you could turn other ways. So it's all real numbers. There's no restrictions. And the range will be the minimum to maximum for the y value. Minimum is -1, maximum is +1, and put less than equals here. So this is for y equals sine x. we could use decimals to do the graphing, make sure it's in degrees, and change the x minimum maximum to negative 600, positive 600. Then you will see this graph. If we zoom in, zoom out, you will see this graph keeps going. Okay, so maximum minimum is 1, negative 1. So it's repeated itself. So this is periodic function. Then this is a parent function. Then the peak is at 90 degrees and 1. The trough is the lowest point, is at 270 degrees and negative 1. The equation of the axis, or we call the midline, is y equals maximum plus minimum divided by 2. 1 plus negative 1 divided by 2 is 0. So what does a sinusoidal function looks like? It looks like a wave. So we just say it's like a wave. Okay, so that is for the first sinusoidal function, parent function, y equals sine x. Then next one, we are going to learn transformations to get other graph. So we are going to use decimals and make sure that it's in degrees, and the x-axis will be from negative 360 to positive 360. So using this one to plot sine x plus 2 and sine x minus 3 and see what will happen. So we are going to continue graph y equals sine x plus 2, then y equals sine x minus 3. Compare, then you will see it's just a parent function, the right curve up 2 and down 3. So we can graph the parent function here, then just move the graph up 2, down 3. So we are going to graph the parent function first, and to graph the parent function, you can think that the 0 degree is from middle, then you go up to 1, then down to 0, then continue down is negative 1, then go back to 360 degrees. So this is 90, highest point. So we could draw it is 1, 2, 3, 4. So 0 is start from the ground is 0, then 90 go to the highest point is 90. So you could think of the Ferris wheel. So you enter at middle is the ground, then up, then down. So treat the middle as a 0. Then 180 go back to the enter point, then 270 down 1, then 360 go back to the enter point. So this is your parent function. So we try to graph parent function. Start from parent function each time. So this is y equals sine x. And for the plus 2, it's just all the y value up to is same with quadratic function plus q. Each one up to, then you have a new graph. So this is y equals sine x plus 2. And the minus 3 is just all the graph down, the parent function down 3. So from here down 3, down 3, middle, down 3, down 3. Then connect it, connect them together. This is y equals sine x minus 3. Then it's done. So this is a Q value. So this one is amplitude is still from middle up. The shape doesn't change, so it's same as a parent function. So we just pick the last one to fill in this parent function, the amplitude. The period, the shape doesn't change, the period doesn't change. The domain is all real numbers, still same. And the range changed. The minimum is -4 to -2. So the original -1 to +1 minus 3 becomes -4 to -2. So y belongs all real numbers. Then -4 is minimum, -2 is maximum, y in between less than or equal to, less than or equal to. So this is for the sine x, y equals sine x plus a number, and that number we treat it the same as q, same as the vertex pq. So q is up down. Then we are going to continue to see if it's x minus p, then what will happen? Is it similar with what we have done before for vertex? So vertex, this is your p value is left right, and we are going to graph and see if that p value controls left right. If x minus p, then it means it will be opposite. So this one we delete, and graph. Y equals sine x minus 90 degrees, and see what will happen. So you will see from here to, I will change the step to 90. So you will see it is to the right 90 degrees. So minus 90 to the right. Or we could change this one to P and add a slider. And we are going to change that one, the step to 90. So this one we could change from -360 to +360. If p is 0, you will see it's same. And if p is positive, it goes right 90 degrees, continue. 180 degrees, 270, 360. Then if we have the p value is 0, same, p value is negative, it goes left 90 degrees, left 180 degrees. So it is p value controls left right. Then we just, this one we graph the parent function right 90 degrees, this one left 30 degrees. Then we are going to be able to graph these two. So we graph the parent function again. This time we don't have the shape change, so we could graph it, go by 0.25. So negative 0.5, negative 1.0 for parent function is 0. Then the unit circle we go up to the highest point 1.0, then go back to middle, then this is 180, this is 270. This is 360 degrees. So this one is the middle, and 270 degrees will be down to the lowest point, and 360 at middle. Then we connect them. So after at 90 degrees, it's go to the right 90 degrees. So all the point go to the right 90 degrees. So this one middle, this one the lowest points, and connect them. And because every 360 it will repeat, so another point will be here. So it will go this way, then continue. 360 degrees will be here. 360 degrees. This one will be the highest point, this one at middle. So you could continue all the points, 360 degrees, then continue go. And this one plus 30 degrees will be left 30. So this point, every 30 degrees is 1 grid. So left 1 grid. Then connect them. You will have y equals sine x plus 30 degrees. The blue one is parent function, y equals sine x. And the red one is y equals sine x minus 90 degrees. Okay, so this is for the p-value. P-value is left, right, and it's opposite. Minus 90, p is positive 90 degrees. Plus 30, then the p-value is negative 30 degrees. It's left 30 degrees. And amplitude, we are going to just pick the g at x to describe the amplitude and period. So amplitude, the shape doesn't change, still from middle to the maximum is same. Period, it didn't change. Domain is all real numbers, no restrictions. Still, for the range, it will be no change. Maximum, minimum for y stay same. So now we have done p and q. And after that, we are going to see the a value at front of the function. So multiplying what we are going to have. So we are going to use decimals again to check what happens to the 3. And we know that for quadratics, the a value is all the y value of the vertex of the quadratics will times by that a value to change the step pattern. So y equals sine x and y equals 3 sine x. Then you will see the period is same, only the amplitude changed from 1 to 3. So the y value times by 3. And also I could change the a value, the 3 to a at the slider. And you will see if a equals 1, they are same. A equals greater than 1, then it's stretched. The stretched number is same as a value. And if a is -1, then the graph, it is flipped. So a value, numerical value greater than 1, then the graph is steeper. So it's just all the y value times by this a value. So now we are able to graph it as long as we know how to graph the parent function. So this time the amplitude change, maximum, minimum value change. So we are going to go by 1 again. 1, 2, 3, 4, -1, -2, -3, -4. Then we are going to graph the parent function for the unit circle, enter from the middle, then up, then down. Okay, so 90 degree to the highest point, 180, come back to the middle, then 270 to the lowest point. Like 80 degrees, then 360 goes back to the middle, then connect them smoothly. This is parent function y equals sine x, and for the y equals 3 sine x, all the zeros times anything give you 0. So these 3 points, they are now going to change. Only those y and the -1 times by 3, it will change. Only 2 points changed. Then connect. This is y equals sine 3 sine x. So y equals 3 sine x. And for y equals -2 sine x, it's just all the y value times the parent function times by -2. So the zeros won't change. 3 points won't change, only 2 points. -2, -1 times -2 is +2. So the whole graph flipped. So this is y equals -2 sine x. Then the last one is half. So 1 times half is middle. So -1 times half is middle. So connect it is just less steeper. So this is y equals 1/2 sine x. You could extend it to by at 360 degrees, the graph will repeat to graph the whole thing. So amplitude, we are going to use the last one to fill in this amplitude. So the last one is from middle up. It is 1/2 overall height divided by 2. So 1/2 to -1/2 overall height is 1 divided by 2 is 1/2. Period, it didn't change. It's still 360 degrees. It's still 1 cycle. And the domain, no restrictions, the range changed from -1/2 to +1/2. Minimum is 1/2, maximum is 1/2. Then it's done. So from here we have done a sine x minus p plus q. And a is vertical stretch, a times the y value to do the graph, p is left right, and q is up down. And the next one we are going to see if we have a number at front of the x, what will happen to the graph. So this one sine 2x, sine 3x, sine 1/2x. Use a decimals, we are going to check what will happen to the graph. So delete this. Now y equals sine 2x. Then you will see in one period from here to here. Before we have only one cycle, now you have 2 cycles. So for the green one, the cycle changed. The period changed from 360 to 180. Now we are going to graph y equals sine 3x. Then compare this. So this one cycle is 120. So every 360 you will have 1, 2, 3 cycles. So the number in front of x tell you how many cycles in 360. So the cycle changed. And another one, y equals 1 or 2. Sine 1 or 2 x. Then you will see this cycle changed from 360 to 270. So the original one is 360. Now the cycle same point is 720. So in 360 you have only half cycles. So the k value tells you how many cycles in 360. So we are going to see this is 0 degrees. The parent function, we are going to do the graph. 0.5, 1.0, negative 0.5, negative 1.0, and 270 degrees, 360 degrees. So the parent function, 0, then 90 is the highest point, 180 middle, 270 lowest point, 360 middle. So the sine is your y value, so it's just same as a unit circle the height. From 0 degrees, go up, highest, 180 middle, 270 lowest point, and 360 go back. So the y, the height, give you the sine. So this is a parent function. And if you remember, 30 is 0.5, so you put one more point, it will help you to graph it more accurate. Okay. Thirty degrees, the RA 30 give you 0.5. So this is parent function, y equals sine x. Then for y equals sine 2x, that we know that in one cycle we have 360 we have 2 cycles. So from here to here you have 2 cycles. Then in other words is all the x value divided by 2. So 90 becomes 45, 180 becomes 90, and this one becomes 135. And 360 divided by 2 is 180. All the x value divided by 2, then you will have 2 cycles in 360 degrees. So repeat this one. Add 180. Now this cycle is 180. So you add 180, then you will have another cycle. So this is y equals sine 2x. 360, you have 2 cycles. Then the next one is 3 cycles. So 120 will be 1 cycle. Then we could graph it as the middle point will be middle, and this quarter point will be the highest point. This quarter point will be the lowest point. Then we have this cycle. So this is y cosine 3x. And how I graph it, I use one cycle is 20 degrees. So 120 degrees, then it will be quarter points. Quarter points will be the highest point. So this is a period, but now it's not 360, it's 120. Within 120, you are going to finish the same cycle. So quarter of it is 40, quarter of it is 30 degrees, then quarter 60, quarter 90, quarter 120. So 30 degrees is highest point, 60 degrees is middle, 90 degrees will be the lowest point, and 120 will be the middle. So this is using the quarter points to graph y cosine x. And this one over 2x. 1 over 2x will be 720 degrees. So 720 repeat. Then the middle of 720 will be this part. And the quarter of 720 is 180 will be the highest point. So you will have this one, then go back. So this is your y equals sine 1 over 2x, and you could extend it. Every 720 repeat, so 720 will repeat here, negative 360. And for this one, this middle will be the lowest point. So this is a y cosine 1 over 2x. Then the amplitude, we are going to use the last one to determine the information of amplitude period. So amplitude is still no change. Maximum, minimum, same. So amplitude is still 1.0. The period now is 720. So the k value 1 over 2 tells you in 360s you have only half period. So the domain is all real numbers, no restrictions, and the range is same as before. Y belongs all real numbers, minimum -1, maximum 1, then less than equal to 1, y less than equal to 1. So now we have covered all the parameters. So a sine bracket k bracket x minus p bracket plus q. So there's more than one way to graph it. You could graph PQ, that is your starting point, then find the quarter points. So or you could graph the parent function, then use a stretch. A value times y, the k value is x divided by k, then p value is left right, q value is up down. So the x over k plus p, a times y plus q are the new points from the parent function. So A is vertical stretch, if negative, reflect on the x-axis. K is 1 over k horizontal stretch. If k negative, reflect on the y-axis. P is horizontal translation, plus right minus left. Q is vertical translation, plus up minus down. And this also could apply to general function. So if you have other functions, for example, you have absolute value function, you have the quadratic function, you have the square root function, it's same AKPQ transformations. So if we want to use a shortcut instead of a times y plus q x divided by k plus p, another way you can graph it is start with point pq, then find the quarter points as the following. So start from this one is your pq value, then the quarter points is this one. Add the a value, even if the a is negative, then it will be minus a. Then quarter point, this is another quarter point, will go back to the q value, and this one will be q minus a. This is q plus a. So here a could be positive or negative. So that is what written here. So you start from PQ, this is your PQ points, and then the whole period you have another point. At middle, you have the same point, and middle again, it will be Q plus A. If A positive, it's up. If then another one, quarter will be down. If A is negative, then it will be down first, then up later. So you connect them, you will have a graph. So the important thing is you need to find the PQ value, then the whole period you find another point. Middle of the period is go back to the same point, then the other point is up or down based on the A value. So quarter you will be able to graph quickly by using quarter points. Quarter points means a quarter of the period. The period is 360 divided by the K value. This is period. So after that, we are going to see how we can graph it. So this one, negative 3 sine 2 times x minus 30 degrees plus 1. So from this one, we are going to determine the AKPQ first. The A absolute value is amplitude. A is not amplitude. It's connected with amplitude. K is 2, P is 30, and Q is 1. So if we practice with a shortcut, it will be find the 30 degree and 1. So go back 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4, and 0. So 30 degree 1. This is your starting point, and the period we need to find. The 1 sec period is 360 degrees divided by 2. The K value means in 360s how many cycles. So divided by 2 is 180 degrees. So you have 2 cycles in 360. So the first point is PQ is 30 degrees 1. Then from 30 degrees plus 180. That is your 1 cycle point. So the middle is y equals 1. So this is y equals 1. That is your midline. y equals q is your midline. And the middle of this 30 and 1 give you 30 plus 2, 10, give you 240 divided by 2 is 120. So midpoint will be 120 here. This is 3 points. So 120 degrees, 1. We just need to find the other 2 points. We find the midpoint of 30 and 120, 150, 75. It will be somewhere here. But the A value is -3, so from this midline down 3. 1, 2, 3. This is 75 degrees, then -2. 1 minus 3 give you -2. This is the midpoint of these 2. Then quarter points, midpoint of 120 and 210 give you 330, 165. 165 will be between this 150 and 180 middle. Then this one will be -8 will be up, -3, it's up 3, 1, 2, 3. Then connect them. So this is y equals -3 sine 2 bracket x minus 30 degrees plus 1. So this is a new graph. Or you could do the other way is I will show you another way you can do it is draw the parent function y equals. So I will draw the parent function here. So this one, middle again, then up 1, down 1. So this is your parent function y equals sine x. Another way you can graph it is using transformations. So y equals sine x. Then we are going to stretch. So -3, all the y value times by -3. 0, 0, 0 don't change. This one -3 will be here. This one -3 will be up. Then we are going to do the k value divided by 2. So this one 2 will be here. And this one half. This one half will be here. So this one +3, but half will be 135 will be here. So this one will be I put all the stretch together. So y value times 3 and x value divided by 2. So this one is the green one is y equals -3 sine 2x. Then the PQ is just move it around. +31, so it's 30 degree, right 30 up 1. Then you will see right 30 up 1, right 30 up 1. So this point is not right, it should be 3, not 4. So this is so this green one is 3 and 135, so it should be here. So this one is right 30, up 1. So each point is 30 degree, right 30, up 1. It will give the right graph. So there's one way is just find the PQ, then the whole period is 180, find the corresponding point, then middle is the midpoint again and the same midline. Then based on the A value, if A is negative, then down first, up second. If A value is positive, then up first, down afterward. So that is how you do the graph. Or another way is graph the parent function, then do the y value times by -3, then x divided by 2. So to find those points. Then we are going to see the amplitude for the right. The right one is your final graph. So amplitude for that one is from the middle is up and down 3. So amplitude is overall height divided by 2. It is numerical value for the A, absolute value for A. The period now is 360. You have 2 cycles, so the period is 360 divided by K. It is 180 degrees. The domain is all real numbers, no restrictions, and the range is y value from minimum to maximum. Minimum is -2, maximum is +4. Then we have -2 to +4. So that is for one transformation using AKPQ. And the next one is applications. So the height above the ground of a rider on a Ferris wheel can be modeled by the sine function. This is an application of the sine function. So where h at x is a height in meters and x is an angle in degrees, that's a radius from the center of the Ferris wheel to the rider makes with a horizontal. So if we sketch it, this is the Ferris wheel, then the x is a degrees, that's the radius from the centers of the Ferris wheel to the rider, formed with a horizontal. So this is your x. Graph the function in degree mode and determine the maximum minimum height of the rider. Determine the measures of the angle when the height of the rider is 40 meters. So this one, 25, 27, 2, and 90. So A equals 25. K equals 2. P equals 90. And Q equals 27. For application question, for the larger number question, the easier way to graph is find the PQ first, then use a period. So we are going to find the PQ is 90 and 27, and the period will be the 360. You have 2 cycles, so period is 360 divided by 2 is 180. So we need to graph at least one period, so the horizontal will be at least 270. So we are going to see, we may go by 30, 60, 90, 120, 150, 180, 210, 240, 270. So at least one cycle. 300, 330, 360. So 90, 27, and it's go up 25, go down 25. So the maximum will be 50. We could go by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, yeah, off a little bit, so we are going to put 52, a little bit extend. So 27 is starting, 90, 27 is here. 90, 27 is your first point, and the cycle is 180, so plus 180 is 270. 270, it will repeat itself. And the middle of 90 and 270 is 180. It should be at this middle again. So we are going to draw the midline. So 3 points will be on this midline for the y cosine x. So this is y cos 27 is your midline. On your midline, you have PQ, then 1 period, half period, and after that, the 25 will be quarter points. So this is 180, 27. 90 and the 180 add together divided by 2 will be 135. So this is 135 and go up plus a, so from here go up 25. This one is 135 and 52 plus a. Another point is a middle and down, a minus a, so 180 plus 270 divided by 2, it will be 225. It's here and down 25, it will be 2. So this is 225 and 27 minus 25 give you 2. So now you have the graph. So this is how you find all the quarter points. It just from one period find the middle, then from these 2 points find the middle again, and this point is Q plus A, this point is Q minus A, and Q is middle of your graph. And also we could extend to the very beginning, so this one minus 180 will be 45, so 45 will be 2. And this one, 180 minus 180 give you 27, so it will be 27. Then you have the whole graph start from the 0 degrees. So this is height, h at t, or h at x, in meters. So this one is 52 meters. And determine the maximum and the minimum heights. From here you will see the maximum height is just a Q plus A is 52. And the minimum is Q minus A give you 2. Determine the measures of the angle when the height of the rider is 40 meters. So 40 meters. We could roughly read from the graph, or we could solve for the trig equation. So we could just roughly read from the graph is 130. Each of them is 15 degrees, is 105 degrees, and another one is around 150 plus 15, 165 degrees. Then for solving this more complicated equation, we are going to do it in future. Okay, so that is how we graph the application sine function. So start from the PQ, then after that add one period, you have the same point and middle point on the same midline, and quarter points is Q plus A, another quarter point Q minus A. So thanks for watching.